All right, today we're going to talk about composition of transformations. What that means is you are doing more than one transformation on a figure. So here's some definitions above. So let's take a look at this. This is the notation for a composition of transformations. So remember what you're doing is you're starting off with a pre-image. You are going to transform it in some way. Then you're going to take that image and you're going to transform it in a different way. So this is telling you to translate your figure, that would be each vertex, 3 units in the positive direction. So you would add a 3 to your x value, 4 units up. So you would add a 4 to your y value of each vertex of your figure. After you do that, your new image that you created, what you would then do is you would reflect that new image across the x-axis. So you would just apply the rule for reflection across the x-axis in this case, which would be to change each one of the y values to their opposite. All right, so here's another example of the composition of transformation notation. You're reading it from the right to the left. Here's a rotation 90 degrees. Remember, it's always counterclockwise unless specified. And then after you rotate that particular figure, whether it's a triangle or a square, you're then going to translate it 2 units to the right. Here's another one. First, you're going to reflect across the y-axis, changing your x values to their opposite will get you that result. After you do that, you're going to take that new image and you're going to reflect over the line y is equal to x. All right, so here's a visual. So here's number 1, and it gives you the coordinates. And the first thing that happened is a reflection over the y-axis. And then the second thing that occurred is a reflection over the x-axis. Now this is also called a double reflection across intersecting lines because these are the coordinate plane and the x and the y-axis intersect. So if you do a double reflection over a set of intersecting lines, you could get to that same ending result from 1 to 3 by rotating it 2 times the degree of the intersecting lines. And I'll show you that at the bottom. So this is a 90-degree angle here because all grid lines create 90-degree angles with vertical and horizontal lines, and 2 times 90 is 180. So this is also an example of a 180-degree rotation. Okay, so here's some good videos, and I'm going to post this video right here so you can link to that. Let's see, real quick, let's take a look down here at the bottom. There are 3 main types of compositional transformations, but any type of compositional transformation, like you can see up here, could be performed. These are all, so far that we've talked about, are congruent transformations. This rotation, this translation, this reflection here, these are all congruent transformations. So it's not to say that you couldn't have one that wasn't, but so far that's all we've talked about. So these 3 main types of compositional transformations is when you're doing more than one thing, and these are very specific. So this first one's called a glide reflection. A glide reflection is a congruent transformation. So you can add that to your list, which was rotations, reflections, and translations. The fourth one is called a glide reflection. They're also called rigid motion and isometry. So what a glide reflection is, it's literally just a combination of, hey, I'm going to reflect and then I'm going to slide, translate, reflect, translate, and then that pattern continues. It could start with the translation first and then reflect, as long as it continues that pattern. Next, this is called a double reflection over a set of parallel lines. So what's happening here is you start at this triangle ABC. I reflect over this first parallel line to get this triangle A prime, B prime, C prime. Remember, with reflections, you've got equal distance between your vertices and the line of reflection. So this line A is my first line of reflection, 2 units from A to the line of reflection, 2 units from A prime to the line of reflection. Same thing with B. This little segment here and this little segment here are the same distance apart. All right, after this reflection, another reflection has taken place where this is your second line of reflection. So I then created triangle A prime, double prime, B double prime, C double prime. And once again, a reflection, everything is equidistant, perpendicular away from the line of reflection. Okay, so things that you need to know is that I could have achieved this starting point to ending point, pre-image to image, by just sliding my original pre-image triangle ABC across this coordinate plane 2 times the distance between those parallel lines. So the distance between these parallel lines is 5. So if I would have taken my triangle and literally counted over 10 units to the right from each one of these vertices, here's C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of those vertices 10 units over, then I would have gotten to that image, double prime image, the same way. A different way, but the same result. Okay, and that's always the case. So anytime you have parallel lines, a double reflection over a set of parallel lines, you could have gotten to the same ending place, same mapping scenario from this triangle to this triangle, a second different way. All right, which brings us to the third very popular type of combination of transformations, and that's called a double reflection in intersecting lines. So just like we saw above, if you have a set of intersecting lines, and you do a double reflection. Here is my original pre-image, and then I reflect over this line here called A, and you notice it's intersecting with line B here. So there's my first reflection. Here's my second reflection. Well, I could have achieved this end result here by just rotating the original pre-image to the image, and that angle of rotation would equal 2 times the angle that's created. Here it's marked with a little theta. It's just using a little symbol to mark the angle measure. So if this was a 20-degree angle here, then the angle of rotation from this center of rotation here, starting at each one of these vertices right here, vertex A, then this angle here would be 40, 2 times whatever this intersecting line's angle is. And that's what it says right here. All right, so let's go up and look. You've got some notes. This is a really good one. It gives you even a really good video explaining these three, really good. So if you click on that one, the CK, you got some notes right here. And I think I did see a video. You can read some notes about your glide reflection, reflecting over parallel lines, reflecting over intersecting lines. And then this video right here specifically gives you some more information on those 3 scenarios. So if you need that, you can also click here for math bits. This explains how to read that notation again. Some examples of a combination of transformations, and then here once again explains you these 2 pictures. Pretty good. These 3 pictures, excuse me, really good. You can also go to practice and get some practice in here, and these are immediate feedback practice. So if I think that's the answer, nope, that's not the answer. So you get immediate feedback. So this says, starting at this point right here, it says which single translation will produce the same image as the following sequence of translations. So this is telling you to do this first. So I would subtract a 1 from the -4, and I would add a 5 here. After I get a new A prime, that then wants me to do this to my new point. After I get a new A double prime, it then wants me to do this. So 3 things, okay? So then it's asking you here, instead of doing all 3 of those things, you could have just did one of these translations. Which one was it? That's what the question says. So for example, here it says, hey, I'm going to subtract a 1. So that would be -4 minus 1 is -5. Adding a 5 here would give me a 0. So that's -5, 0 is my A prime. And then I go down here. -5 plus 4 is -1. So that'd be plus 2 to the 0, -1, 2. All right, and then I go down here. So that makes it, adding a -5 to a -1 is -6. I had a 2, and negative 7 is negative 5. Okay, so I think I ended up with negative 1, negative 5. So I think that's what I ended up with. I lost count, but hopefully you figured out what I ended up with. So I'm not even sure anymore. So you might have to go back. I'll have to write it down. I don't have any scratch notes here to do it for you. Do I? No, I don't. Let's see if I can. Can I? Oh, let's try it. All right, here we go. So our A prime, yay. Our A prime is going to be me adding the negative 1 to the negative 4. So that makes a negative 5. Okay. And then adding a 5 to the negative 5, that gives me a 0. Okay, dokie, this is fun. All right, and then for the A double prime, because this would be that second transformation. So using this, I'm going to now follow this rule here. I'm going to add a 4, so that gives me a negative 1. And then I'm going to add a 2 to the y, so that just gives me a 2. Okay, so there is my double prime. And now for my third, so that's 3. There we go. All right, using this point here's coordinates, I'm going to subtract 5. So that would be minus 6, right? Okay. And then I'm going to subtract 7, and that's a negative 5. Okie dokie. All right, so this is going to be my end result. So the question is, how could I have gotten here without doing all these things? Okay, which one of these rules using my original point could have gotten me here? So this would be me adding a negative 2. This would be me adding a negative 2 here to adding a negative 2 there. Or I can just say minus 2, right? And then this one, I need I'm doing nothing. I literally am doing nothing because I want to end up with the 5. So that would be this guy right here. So let's see if I can get rid of that. Okay. I don't know if I got rid of that, but that would be the answer right there. I don't know how to get rid of that. Sorry, guys. But that would be our answer right there. La, la, la. Okay. All right, let's go back. All right. Anyway, there it is. And here's a PowerPoint too. If you need to look over some really cool notes about compositional transformations, please click on that. I can't for you, but there it is. If you have any questions, just shoot me an email. This one's a true or false. Looks like you're looking for the false. Read these carefully, of course. It could be one word that could make the whole thing false, all right? And that does remind me up here. Remember, you always have to follow compositional transformations based on the order that you're given. So in that example that I gave you a minute ago, if I would have started down here first and worked my way this way, I wouldn't have came out with the same result. So do make sure you are following your order of order that you are asked of these compositions. Okay. All right. Email me with questions.